Welcome everybody. We have a new battery from VATRER. I'm probably mispronouncing that, but this is made for 48 volt golf carts. It's a 51.2 volt lithium battery with a self-heating function, which is why I'm so excited to test it. I plan on doing a conversion of my 50-year-old 36 volt golf cart, and I'll try to use this battery in that project, but I'm in the cold north, and so having a self-heating battery should really be a benefit. So we are definitely going to test the self-heating function of this battery. We'll also do a capacity test and a current test on it. So let's get going. Hi everybody, I'm David, and let's break into this battery and check it out. Now I believe this kit currently sells for about $1,700, but I'll leave a link in the description below along with any coupons that might exist. Wow, so this cardboard is very thick. It looks like 3 layers of cardboard. I mean, look at this. We have the battery here surrounded, and then they've got charging and stuff in here. So color instructions. This says LCD display. It might just be a spacer, but I'll check it out just in case. And the charger. So this 20 amp charger that comes with it, it doesn't have an IP rating that I can see on here, but usually this style is waterproof for the sake of mounting it under the golf cart with the battery, and if you get any splashing up on it, it's fine. And it looks like it has closed loop communication with the battery. But we'll check all that out. And the battery itself. So check that out. It's a nice looking battery. Okay, I was a little bit confused here because it says right here 51.2 volt, but then down here it says 38.4 volt. So a little confusing. I'll let them know that's something they should update. They're pretty good about updating things right away. So we have our positive battery, our negative battery, vent, Bluetooth, CAN, RS485, and our on-off switch. I heard it click. Usually these have relays in them because they're rated for 200 amps. All right, so we've got our battery, got our cool smart charger. All right, so we've got our 120 volt cord, which I'm gonna plug in over here to a meter, so we'll be able to watch that. And let's check out our display. And our cool little display. Oh, and they potted this. The last one that I looked at had more exposed circuitry on the back. Looks like we have a little bit right here where the cord plugs in, but for the most part it looks like we got a lot of like potting material around there, waterproofing material. So they clearly are trying to get better because that was probably a complaint on the last one. So I'm reading the specifications in the manual, and this battery is 105 amp hours. It has a continuous discharge current of 200 amps with a peak of 400 amps for 35 seconds. So that should be great for golf carts. So here's our pretty long cable for the display. And it says to go to the RS485 port. Looks like it's keyed. There we go. And then the display has this little waterproof connection. Before you install, check the components, connect the LCD display, press the on-off switch on the battery. Okay, well that's over here. Then press the switch on the LCD display. So that's going to be this button over here on the side. Awesome. That started right up. Didn't have to download a firmware or anything. And we have all 16 cells. Well, next step is to hook up the charger. We'll want to bring it up to 100% before we do any load testing on it. So let's turn it off. We have a bunch of different bolts. These bolts look like they come with the nylock washers. So this would be bolting it to the frame. Here's some smaller bolts with nylock washers. I assume this is probably for securing the charger to the frame if you're going to have the charger inside. And then finally we have our positive and negative rubber boots here, along with a couple of bolts for the battery terminals. On the ends of this wire, it shows the brown is positive. These are 13 millimeter. Since the display is connected to the RS-485, I'm going to try connecting the charger over to the CAN port. Let's see if that works. Right. So they have a little keyed connection here. I heard the charger click. The charger has a little light. And the current on the display is going up. Good, 20 amps. That's what the charge is rated for. So let's see how efficient this is. We're charging at 20 amps and 53.96 volts, 97 volts equals 1079, and we'll divide that by 1219 for this. We've got 88.5% efficient. All right, I'm going to let it charge and we'll come back and do some more capacity testing. So when I've worked with chargers like this one in the past, they will hold the voltage, which right now it's doing. It's holding a constant voltage, and it'll do that until it reaches 10% of its rated output. This is a 20 amp charger, so when it reaches 2 amps, it would shut off. I don't know if it's going to do that, or it potentially might shut off when the BMS shows one of the cells at 3.65. Don't know. We'll find out together. Oh, there it goes. It beeped and shut itself off. So it did shut off at 3.65. We are all ready to begin the capacity test. We're going to discharge this battery over the course of about 5 hours. We're going to measure all the electricity using this shunt, which is connected through Bluetooth to an app on this phone. We'll time it, and our load is this big load bank that I built in a previous video, and it's just a whole bunch of water heating elements and DC circuit breakers, and we'll turn it on, and we're going to aim for about 20 amps. Which will discharge this over the course of about 5 hours because it's a 105 amp hour battery. So let's begin. Let's turn it on. So we're going to zero out the history. There we go. We're all zeros, so we're going to be looking for that. And let's go ahead and begin the timer. Okay, timer's running, and let's turn on some breakers. Like, what happens if we turn on that one? Well, if we turn on that one, that's a 22 amp. And it's showing over here, 22 amps. So yeah, let's let that run. That'll probably be good. The capacity test is running. We will catch back in about 5 hours and see if we can hit our 105 amp hour rating on this battery. Well, this display really warns you not to run out of juice. Still have a little bit more to go. Well, this tank of water is getting very hot. I don't even want to touch it anymore. That's too hot. And let's check it out. Well, we're down to about 44 volts there. We're still discharging. Over here on this screen, it says we have 4% left. And let's check out our voltages. Yeah, so we're so close to dead. I mean, the lowest one here, 2.6 volts. So 2.5 volts would be the cutoff. We're over 5 hours. So yeah, this battery is dead. Just limping along here if you were in a golf cart. And let's check out our history. 107 amp hours. 5.5 kilowatt hours. Well, that is excellent. But if we go inside, we can get a better accurate reading. 137 degrees. That is hot. And, oh, it just stopped on me. So at 5 hours, it just stopped. Well, that's great. This battery surpassed its rating. It did fantastic. It's rated for 105 amp hours, and that is just under 5.4 kilowatt hours. During our test, we measured 107 amp hours and 5.5 kilowatt hours. So it surpassed its rating in our test. That's great. So I'm very impressed with it, and that was the very first discharge test. Right out of the gate, it did it. I'm going to throw the charger back on here, and tomorrow when we catch back, we'll do a current test. Good morning, everybody. Well, it's the next day. The battery is charged up to 100%. I've reconnected our discharge lines, and we are ready for an overcurrent test. Now, the manual says that this can do 200 amps continuously. So we'll see if we can do it. That will be really great if it can. I'm kind of worried that it's going to shut off a little early just for temperature. It might get too hot inside, but we are going to find out together. So here we go. We'll zero out the history just for fun, but this is not a capacity test. And we are zeroed out. So over here, we'll start turning on our loads. There we go, that's all of them. And shows we have 207, and this is showing 205. So very close to each other in amperage, but we are a little bit over that 200. So let's go shut something off. So let's shut off this one. And we're at 197. So that's as close as I'm going to be able to get with my setup. 199, 197 showing. And let's start our timer. And we're just going to let that run as long as it can. Over halfway there, and everything's looking great. We're seeing 40% over here. It's showing 198 amps. This is showing 196. So they're very close to each other. 19 minutes in. So everything is doing great. Well, 30 minutes into the test and it is still running. So this was a huge success. We're still doing fantastic over here. Let's take a look at our history just for fun. 5.1 kilowatt hours, really good. Again, this is not a capacity test, but just for fun, we check that. Well, that current test worked awesome. This battery discharge, it is true to its word for its 200 amp rating. We were pulling between 196 and 198 amps for about 28 minutes. And then right around that 30-minute mark, we kind of dropped off the knee and the voltage started going down, and that meant that the current was also going down. So we went down to about 188 amps just for the last like 2 minutes of the test, and then it shut itself off. But fantastic, really well done. I'm super thrilled that the BMS inside here, the battery management system, did not shut off early due to overheating or over temperature. It really worked well. We just did the thermal imaging with this little thermal imager here on my phone. The hottest part of this battery is these terminals where we were bolting on our cables, and the cables themselves are warm. Now this tank is super hot. So discharging 5 kilowatt hours into about 50, actually the top is down a little bit. It might be more like 45 gallons. Really gets the whole thing really hot. So we're gonna charge this back up, and then we'll open it up and we'll take a look at its heating pads inside, take out one of the temperature sensors and do a a self-heating test on this. So let's keep going. We've charged up to 41%. Everything's looking good. I'm ready to take this apart and look inside. And now we'll pop these screws off the top. They are 8mm. Okay, let's take this off and see what we got. So the inside of the cover doesn't have anything on it. It's nicely bent. There's a thick foam weather stripping all the way around the edge. And it looks like a plastic insulator at the very top. Everything looks really well built. There's the little Bluetooth module. It has a little antenna that comes out the other side, right there. So you can connect it with your phone if you want. All those bus bars bent really well. Down in there you can see the contactor. Down there at the very bottom you can see the contactor, the big black item there. It's got bus bars up to the BMS. It looks like they're mounted on a large piece of aluminum. I think I have a BMS like that one. Let me find it. So this is a BMS very similar to the one inside this battery. The prominent feature is a large contactor sitting here. So all the amperage is moving through this contactor. That way you don't have a bunch of little MOSFETs getting hot. The logic board itself doesn't carry any current. Over here on this side of the logic board, you can see a shunt. So it's measuring all the amps moving in and out through the battery. And this is where all the leads would hook up. So this is the idea of what's in here. And I think having a contactor-based BMS is an excellent choice for a golf cart. So that's a good thing. All right, so we just looked at it on the thermal imaging, and I can tell you that the aluminum jumper bars here are hotter than this black surface, but the black surface showed up hotter. It's because the reflection of the shiny aluminum doesn't give an accurate IR reading. But yeah, everything's looking good. And I can see the silicone heating pads in here. And it looks like we have 4 of them that I can see. 1 on each side and 2 in the middle. So down here, this is a silicone heating pad, the orange. Here we can see it also. So there's 2 pads in the middle, and then we also have a pad over here on this edge. And it looks like it was originally glued to the cells, but it's coming off in a couple of spots here. So probably not as big of a deal because it's still going to warm everything inside the case, but it would be nice if that was better secured to the cells. Now each one of these is a voltage sense lead, but a few of them also have a temperature sensor, like right here. We are about to run a test on the silicone heating pads and make sure that they can heat the battery. So we're currently charging at 20 amps and the temperature is fine. It's reading 73.7 and the lowest temperature is reading 68.1. This little current clamp is around the wire going to the silicone heating pad. And we have this measuring in volts because this current clamp is changing the current reading into a voltage reading so that we can pick it up here. Now, according to the manufacturer, this should be somewhere around 200, 250 watts. So we should see 4 to 5 amps going into the silicone heating pad. So in order to test this, we have our little temperature sensor, and I'm going to spray it with some canned air. And I learned this trick from watching Lithium Solar. He's got a cool YouTube channel. So let's spray it a little bit. So we can chill it. And I just heard it click. So it clicked off. And you can see the temperature is reading 0, 0 degrees, and we got no current going in. And this is reading a little bit high right now. So the decimal place is 1 over from where it should be. Should be 5 amps that we're reading. It's 1 decimal place over. So we're reading about 5.9 amps going in right now. And that's because we're a little bit higher in voltage. So the amperage would be lower if the battery voltage was lower. And as you can see, the sensor is warming up. And as that sensor warms up to, I think it's 5 degrees Celsius or about 40 degrees Fahrenheit, I think is what the manual said. I'll have to go check. Then we should see it click and the heating pads will turn off and the charger will turn back on. And it just clicked over. So now it's reading 42 Fahrenheit. And we're charging back at 20 amps and the heating pads turned off. All right, I'm gonna quickly change the camera over and we'll try to get a thermal imaging and see if the silicone pads are any warmer. Overall, this battery is very well built. I'm glad to see that they used a contactor instead of trying to run all the amperage through little MOSFETs. So the contactor should handle amperage for a golf cart a lot better than those little MOSFETs would. But you know, the whole battery worked really well. We got 107 amp hours out of it. It's rated for 105. We were able to do that 200 amp test. So again, around 198 amps for half an hour, fully draining the battery, and that worked fantastic. So if I was to nitpick a couple of things on the cover, I think it said the model was like 31 volt, but it's a 51.2 volt battery, which it is true everywhere else except for that one location. So I think they should edit that. And then the other little tiny nitpick would be on the back of this display. You can kind of see a little bit of maybe potting missing or whatever where this wire attaches. I'd like to see a little bit more strain relief back here so that if you tug on this connector, you're not tugging directly on that little JST, I think it is, connector. Those things are not very strong. So, but if you take care when you put this in place and then zip tie this to your golf cart, that shouldn't give you any trouble. I'm trying to find something to nitpick because overall I think they did a great job. I think getting the battery with the charger and the display all in one box, it's a good value. Nice lithium upgrade for your golf carts. So I'm looking forward to trying to fit this into mine once I get a new 48 volt controller for my golf cart. So thank you everybody so much for watching. If you enjoy these videos, please like, subscribe, comment, share. And down in the description, I'll leave a link for this along with any coupon codes that they might have. Thank you all very much for watching.